Hello, my name is Oğuz Duman, and in this video I will present you a visualization of local alignment. Let us start with talking about the algorithm. Let us have two strings, v and w, that we want to align, and let these strings have the lengths n and m respectively. First, we need to have a scoring schema. This is how we will score the metrics. So we will give plus tau for matches, minus mu for mismatches, and minus sigma for insertions and deletions, aka indels. Note that all these values, tau, mu, and sigma are positive, so we will give rewards for matches and penalties for mismatches and insertions and deletions. When we have those, we need to create a n plus 1 by m plus 1 scoring matrix and insert a 0 in every vertex with at least one 0 index. Then we fill the matrix with the given formula. The formula basically indicates that you should take the maximum of four values: 0, the value at the left up diagonal, plus the match reward or mismatch penalty depending on if the two characters match, the value of the left vertex plus an indel penalty, or the value of the upper index and an indel penalty. So in this formula, you can see that any vertex will be non-negative since we have a 0 in a max relation. After doing those, we will have a full scoring matrix. So we take the largest value on the matrix and trace back until we see a 0. While tracing back, we write each character on both sides of the matrix, which will give us the alignment. Let's go over an example to further clarify. You can see two sequences here of length 11 and 8. We will reward 1 for matches, penalize 1 and 2 for mismatches and indels respectively. Since our lengths are 8 and 11, our matrix will be 9 by 12. So let's start filling our matrix. So as the first step, we need to insert zeros in all vertices which have at least one 0 index. So here is a 0 index, and we will fill this row with zeros, and here is the 0 column, so we will fill zeros in this column as well. So we fill the matrix by using the formula. So here you can see that if two characters match, they will get the reward of 1. And if they mismatch, as you can see here, there's a G and an A, they will get the mismatch penalty of 1. And if there is an indel, as you can see here, there's a C and a T, you will get the indel penalty of 2. So basically, I found the maximum value on any vertex, which is 3, as you can see here. So now let's trace back so that we can find the alignment. So here we have an A and an A on this vertex. So we need to go diagonally. Here we see that there's a mismatch, a T and an A. But we cannot have had a indel penalty because 2 is greater than 1 and 1. So we must have had a mismatch. So we go diagonally again. So there's a 3 here. There's a C and a C again. So we go diagonally. Again, there's a T and a T. There's a match. We go diagonally. There's an A and an A. We go diagonally again and reach a 0, which is the ending point. So here you can see a traceback that is written in a much better manner than myself. So you can also write this yourself and check it. And now let's go to write down the sequences. So after the traceback, we write down the sequences by checking each row and column and taking these characters. So you need to note that the vertex that you reach 0 should not be written, but you should start with the vertex with the positive value. So here you can see the ATCTA, which is written here, and AATCAA, which is written here. And the score is basically the maximum vertex's value. So if you wrote down the matrix and solved it yourself, you could have seen that there's also another tree, not here, but here. So there's an alternative solution. And this is much shorter, but you can see that it is ATC and ATC on the columns and rows. So this is basically the end of the video. Thank you for listening.